This is 2015 question 3b, where the particle strikes the plane at right angles. Now, if it doesn't strike the plane at a right angle, maybe is a good way of introducing this. Let's say it strikes at this angle, coming in this direction at an angle A. The angle A is going to be opposite over adjacent, so the tan of A is equal to the landing angle, or the J component over the I component. But if it strikes at right angles, we can say it's coming directly down, so we have no velocity in the x direction. Velocity of x is equal to 0. So let's read this question. The plane is inclined at an angle 30 to the horizontal. So let's do our diagram. We have our horizontal. My dog is annoying me with a stone. 30 degrees to the horizontal. And initial speed u and angle theta to the incline. So up with initial speed u and theta to the incline. So our initial vector is up the plane. So it's going to be u cos theta in the I direction plus u sine theta in the j direction. And the particle is going to strike the plane at right angles, straight down in this direction. So we have, let's just do a little diagram here. We have it going like this, just say. So s of y is equal to 0 at 2 points, here and here. And we also have velocity of x is equal to 0. So we need to get displacement in the y direction equated to the velocity in the x direction, these two equations, and we should be able to then get the answer of the time of flight being this guy here. So let's see how this works out. Let's put our accelerations in here. Our acceleration, we have a 30 degrees, so it's going to be minus g sine 30 in the I direction and minus g cos 30 in the j direction. So I'll just put it here, minus g over 2 and root 3 over 2 minus root 3 over 2g. And we'll start with s of y. S of y is equal to ut plus a half at squared. So u of y, or j, u sine theta times t minus 1 over 2 is the half. The a is minus root 3 over 2. We have gt squared. So factoring out my t, I'll get u sine theta minus root 3 gt over 4, and this will be equal to 0 at the point of landing. So my initial time of flight, 0, and u sine theta would be equal to root 3 gt over 4. So I put the 4 here and the root 3g on the bottom. You're all going to do this in one step in the exam in a couple of weeks, I'm sure. So we have the time of flight. We've worked out t for s of y, so that's the velocity of x is equal to u plus at. This is equal to 0, coming down at a right angle. So u cos theta, and then minus g over 2 times t will be equal to 0. So u cos theta will be equal to gt over 2. U cos theta will be equal to gt over 2. So 2 gt, g on the bottom, will be equal to t. So I have 2 times. So let's equate these and see what happens. 2u cos theta over g is equal to 4u sine theta. So you should be seeing tan theta now, over root 3g. Cancel your g's, and we will have sine over cos being tan, so I'm going to multiply by root 3. So 2 root 3u is equal to 4u sine theta. I should have cancelled the u's as well. 4u sine theta, so the 4u will come underneath, and sine theta will stay there, and divide by cos theta. 1 or 2 steps if you want. you would have cancelled your u's before now. So sine over cos is tan. Tan theta is equal to, what have we got, root 3 over 2. We need sine theta or cos theta to get time. Theta, the tan of it, is opposite over adjacent, giving me root 7 on top. 3 plus 4, yeah, root 7. Sine theta, opposite over hypotenuse. So time is equal to 4u by root 3 over root 7. 4u sine theta over root 3g. Well, over root 3g, well, the root 3g will go on the bottom. So cancel your root 3's. And we get time is equal to 4u over root 7g. We hate these thirds on the bottom, so multiply by root 7 over root 7, multiply by 1. Time of flight is equal to 4 root 7u over root 7 by root 7 times g. And then you look back up and you say a little prayer in that split second. 4 root 7u over 7g. 4 root 7u over 7g. You put a little tick beside it. You don't draw a smiley face for the examiner. You just move on to the next question. Be ready for this in 2022, because somebody has predicted kind of that this is coming up.